So let's chat about this a little bit. Which one could be this equation? Well, last week we talked about x-intercepts. Okay, with x-intercepts, we're going to switch the sign. And so these two are 2 and 6. So if we switch the sign and then wrote it out in factored form, this is what we would get. And that answer is this guy. Okay. All right, on the next one. Okay, here's the function. Determine if each statement is true. The y-intercept is 4, 0, 4. Yes, that's true. Okay. The x-intercept is at 4, 0. How could we have figured this one out? Could you have graphed it? The answer is yes. Okay. So if we graphed it, like we typed it into Desmos. Yeah, you're right. The internet is real slow. Yay. Love some good rainy days. Come on. Let's go. All right, so that would give me this. Is there an x-intercept? Does it cross the x-axis? No, doesn't touch it. So this would be false. And then -1 equals 9. So looking at this, we could go to our table and we could go -1. Does it equal 9? Yes. Okay. On the next one, write a quadratic equation to match this graph. Remember, you could change the opposite side of the x-intercept. So this would be x plus 4 times x minus 2. Okay. Now, just to make sure that that actually works, x plus 4 times x minus 2. Is that the same graph? Yes. Okay. Next one, sketch the graph. Again, you could have typed this into Desmos and then just sketch it. Does it tell us any information? William wondered what the price of sandwiches are at the deli should be. He surveyed his customers to see how many they would buy a sandwich at different prices. Here's some data. So each sandwich is $5 and the number of customers, so revenue would be 500. Okay. On the next one, if they had $12 sandwiches and they had 30 people buy those sandwiches, we would have $360. Really weird question. Okay. One of the prices is $0. What is the other price that we could use to maximize the sandwich cost? Well, if we type this equation into Desmos, watch what happens. So we've got x times 150 minus, is it 10x? And then we can go to our table. When we look at our table and we fill in a couple more numbers, we see that it goes up and then it starts going back down. So 15 would be the other time that it's 0. 0 people would buy a sandwich that is $15. That's what that's saying. $15 would be it. Okay, and that would be our other x-intercept. Okay. Now I know a majority of you did not get to 8, so I'm going to give you a second and try 8. Okay, so according to the model, what price should be the sandwiches for him to make the most money? So looking at this table, we see that the maximum amount of money is in between 7 and 8. So it should be roughly like $7.50. Yeah? Don't know how much Chick-fil-A sandwiches are? So how much? Say again? I don't know, a meal now is like $10. Okay, so right now, a Chick-fil-A sandwich is $5.75. Okay, and so this little like diagram thing is saying, hey, at $7.50, they would make maximum price. So they're actually giving you a discount. That's what I'm saying. Okay, at that price, how much money are they going to make? So we're going to take $7.50, we're going to type it into this equation, or we can come into our table and just go, hey, $7.50. So how much money would they make? 562.5. 562.5. Okay. Cool. So again, today we're going to be talking about transformations, but we first have to re-mention parent functions. Okay, so on here, we have this little table. If we take -3 and we plug it into x squared, we're going to get 9. If we take -2 and we plug it in, we're going to get 4. If we take -1 and we plug it in, we get 1, then 0, 1, 4, 9. So all I did was I substituted in these numbers into this equation. Okay, so we're going to graph these points really quick. 0, 1, 1, 2, 4, 3, 9. Same thing on the other side. The vertex for this guy is going to be 0, 0. Y-intercept is going to be 0, 0. The x-intercept is going to be 0, 0. It's concave up. And then we're going to talk about average. Okay, so average rate of change is just a fancy way of saying slope. Okay, you learned this back in 6th grade. So 0 to 3 is where they want us to find it. So 0 is going to be our x1. 3 is going to be our x2. We're going to come over to the chart and we're going to look at when x was 3, what was our y value? Well, that was 9, so that's going to be our y2. When x was 0, what was our y value? That's 0, so that's going to be our y1. So we're going to take these 4 numbers and plug them into this equation. Bless. So we're going to get 9 minus 0 over 3 minus 0. And when we type all this into our calculator, we're going to get 3. Okay, so this is what we're going to compare it to. Okay, so that x squared is what we're always going to compare quadratics to. So these are the different forms that we learned about. This is the standard form. That's where we could find the y-intercept, which was always a constant. The x-intercept form is what we talked about last week. X-intercepts or zeros, those are the same thing. But today we're going to focus on vertex form. Okay, so that's the one we're going to talk about today. Okay, so while you have that paper open, we're going to also have this Desmos activity open. So go ahead, grab your laptop, go to student.desmos. I'll put the code up on the board in just a second. Drag the points to observe how the parabola transformed. So if we move B, what happened? Gets super skinny or it gets wider and eventually flips over to negative. If we move A, what happens? Going up and down, right? Okay. So one kind of transformation we'll explore is called a translation. You're going to need this for geometry. Translation means that we're moving side to side or up and down. Okay, select the graph that best shows x squared translated 2 units down. Okay, so from black to blue is what you're looking at. Okay, so that would be this guy right here. Okay, so it translated 2 units down. Here are the 2 different translations of y equals x squared. Click on the above graph to see each translation. Discuss what you notice, what you wonder. Okay, so for here, what happened? This one on the left, x squared plus 3, what happened? It changed the y-intercept and it moved it up how many units? 3 units. What about this one? It moved it down how many units? 4 units, okay? All right, repeated challenges, vertical translation. So from here to here, okay, we see the difference and it moved up 5, right? So we would write that equation as y equals x squared, and yours might look a little different, plus 5. And so when you try it, it should graph it. Take a second, try that twice on your page. Okay, so on slide 5, here's a new kind of transformation. Okay, so moving these, what happens? Makes it skinnier, or it makes it fatter, or wider. Okay, how is the transfer parabola, and how is it different? How is it similar to what we originally have, and then how is it different? Well, it's the same thing, it's just a different number out front. Okay, we see that the number out front on that right column changes, right? Okay, so looking at slide number 6, some of these equations represent the parabola in this graph. Select the one that does not. Okay, so we've got y equals x squared. That should be right here. Y equals 1/2 x squared, which is right here. And then y equals negative x squared. Well, negative x squared would be facing downwards, right? So is that one represented? No. Okay. Because it would be facing downwards. So it's concave down. All right, go ahead and go to slide 7. Try this a couple of times. You're writing the equation for this one. Okay, so for mine that's on the screen, what I would do is I would say from 4 to 8, what would I be multiplying by? Well, that's 2. So I could say y equals 2x squared. And that would graph that. Okay, take a second, try slide 7. Okay, so Kamaya made a table to help her graph this equation. Okay, describe how the graph will be compared to x squared. So from here to here, from here to here, we see that we're multiplying by 5 or negative 5. Okay, so for right here, we're multiplying by negative 5. And then here, we're adding 1. So how would we describe it? We would say multiply by negative 5 and add 1. Okay, so on slide 9, there are a couple of challenges on this one. So from here to here, we see that we're multiplying by 2, but then we're adding a number as well. Okay, so what are we adding from 8 to 11? From 8 to 11, what are we adding? So we multiplied by 2, and then we're going to add 3. So when I write out my equation, I'm going to get y equals 2x squared plus 3. Now, yours might be a little different. That's okay. Okay. Go ahead and take a moment. Try slide 9 a couple of. So kind of summarizing this. All right, what this means is this negative 1/2. Okay. Negative means it's going to be facing down. That 1/2 is going to make it kind of wide, a little wider. Okay, so 1/2 is going to make it wider. And that 3 is going to move it up 3 units. Everybody see that? Okay, that plus 3 is going to move it up. The 1/2 is making it wider. And the negative moves it or flips it down. Okay. All right. So we're going to put a pause. Okay, baby. Thank you. Okay. So based on your observations of the graph, x squared plus k, or y equals x squared minus k, what will cause the graph? This will cause the graph to do what? And this is going to be move up or move down. Okay. Based on your observations, the graph of y equals x plus h, we didn't have a whole lot of this, squared, or x minus h squared will cause the graph to move left, right. Okay. If we have a parent graph multiplied by a negative number, then what it does is it causes it to look concave down. If we multiply the parent graph by a number, it causes the graph to either stretch or shrink. It says, here's the parent function, and we got y equals x squared plus 3. Okay, we're going to shift the graph up by k units. Okay, what I need you to get comfortable with is this function notation. So we're saying f of x plus k. Okay, k represents that 3. Okay, now if we say minus 3, that's going to be down. Good. Okay, I think that one was pretty easy. The next one, this is always really tricky, and it's almost like you have to think opposite. Okay, so if I have a plus 3, then I'm going to move left by k units, by 3 units, right? So from here to here. Okay, but notice how it's plus, not minus. Our heads go, hey, it's negative, it's going to go left. Nope, not on this one. Okay, if we have minus 3, it's going to move right. Okay, again, we need to make sure that we're comfortable with this notation. This is saying, hey, we're going to move right. I'm sorry, this is saying hey, we're going to move left k units. This is saying, hey, we're going to move right k units. Okay. Here's that negative. Negative reflects over the x-axis. Okay, again, putting a negative out in front of that f of x. Okay, a stretch is a number bigger than 1. A stretch, and I would be writing this down. Stretch is a number bigger than 1. A shrink is a number less than 1. Other words that you might see is a compression for shrink. I think that's it. Okay, so compression means to shrink. Questions on that? Okay. Okay, so I want you to go ahead and take a moment. Based on your observations, how do the equations given the transformation and the vertex of the quadratic function relate? Okay, so we're going to work through these together, or a couple of them together. Okay, so since I have x plus 4 squared plus 1, this plus 1 means I'm going to do what? Plus 1 on the outside means I'm going to do what? Move up 1. So we're going to go up 1. Okay, this plus 4 inside means that I'm going to move left or right. So it's opposite, right? That's the one that we always get really tripped up on. So it's going to be left 4. Okay. Now here's how this all relates. This is why this is called vertex form. Okay. Remember earlier when we said, hey, we're going to talk about vertex form, and here's the equation. I'm going to write this at the bottom. So this is the equation that you'll always see for vertex form. If you take whatever the h value is, the opposite sign of the h value, and your k value, that's where your vertex is. So this would be -4, 1. Can you take a moment? Can you try these two? Telling me the transformations and then tell me where the vertex would be. Okay, so what'd you get for the transformation for this guy? What does -5 mean? Down 5. Okay, what about this? +2. Left 2. Okay, so what would be the vertex on this one? -2, what? -5. Now we don't flip both of those signs. We just flip what the x value is. Okay. Okay, on the next one. So what does that negative out front mean? Okay, so that's called a reflection. Again, words that you want to use for geometry. Reflection over the x-axis. Over x-axis. Okay, that 3 right here is going to mean left 3 and then up 2. Hold on 1 second. I want to draw this really quick. Negative x plus 3. So coming in here. Negative x plus 3. Is it plus 2? Yeah, okay. And x squared. Okay, so look at where our vertex is at. It's negative 3, 2. It's facing downwards. It went to the left 3, up 2. Cool. So even if you didn't know all your transformations, as long as you look at the graph, you should be okay. Okay, so again, your vertex is going to be negative 3, positive 2. Questions? Are we okay? Simple enough? Okay. All right, so now you've got to write the equation. Okay, so you're going to take this guy and then do these things to them. Okay, so if I went up 4, I would write the equation y equals x squared plus 4. Ta-da! Can you try the next couple? And then we'll go over them in just a second. So on this one, you should have gotten y equals x plus 3 squared. And there's nothing out here because it didn't like move it up or down. So you could just leave it like that, or you could say plus 0. Okay. Reflected over the x-axis, y equals negative x squared. Okay. Down 7 and to the right 9. So y equals x minus 9 squared minus 7. Now I know that the positive and negative with the left and right is kind of tricky. That's where most people make mistakes. Okay. All right. Number 5, we've got up 1, right 2, and then reflected over the x-axis. So we got y equals negative, and it's right 2, so x minus 2, up 1, plus 1. You can always check these in your graph. Like you can graph them and then compare it to y equals x squared. You should never get these wrong. Okay? The machine works. So if we just plug in some rando numbers, okay, we can see that it's subtracting 3 and then squaring it and then adding 1, right? Fantastic. So on side 2, he says the minimum value of the machine can make is 1. Do you agree or disagree? Okay, so let me help you. So looking at this last column, what's the vertex? This last column, what's the vertex? Come on, we just went through this. What's the vertex of that guy? Change the sign of this. That'd be 3. And keep this guy. That'd be 1. Is this going to be a minimum or a maximum? And how do we know? We know that's going to be facing upwards, right? So is that going to be a minimum or maximum? Minimum. So that means that this y value is the minimum amount. Okay? So yes, I agree. Because the vertex is 3, 1. And it is the minimum value. Next one. What would be the vertex? Change the sign, keep the second. Change the sign, keep the second. So what is it going to be? So that's going to be -5, -3. Okay, so our minimum value is going to be that -3. Okay, so explain how you can use this strategy. Actually, skip that one, JK. Go ahead and go to slide 5. Discuss with a partner where you see the vertex in the table and in the equation. Okay, take a second, talk to your friend. Okay, so where would be the vertex for this one? Where would be the vertex? Change the sign of the first, keep the second. What's that going to be? -5, -3. Okay. So change this equation so that it has a vertex of 3, -4. Change this equation so it has a vertex of 3, -4. Take a second, try that one. All right, so how would we write this? Well, this would be x minus 3 minus 4. Okay. This question on number 7, you're going to have something like this on your test, and it's going to ask like, which one of the following has the same vertex, or which one of the following has a stretch of whatever. Okay, and you'll have like multiple ones to pick from. Okay, we're going to go ahead and skip over to slide 8 and write the equation for the vertex at -6, -2. Okay, you've got to be able to write that equation. Okay, so that should be x plus 6 squared minus 2. Okay, so again, you can see, hey, this is the vertex right here. Okay. All right, so on your paper, you should have, I think it's that paper. Okay, so sharing a vertex. Okay. So what I want you to do is you're going to complete the front. Okay, complete the front. It shouldn't take you more than 10 minutes. We got about 10 minutes left in class. So you should be able to do all these questions. So the coordinates, telling me whether it's opening up or down. Okay, all of that. You're going to turn this in tomorrow. Okay.